This is a short example on how to use confidence intervals um, and error with these confidence intervals. So here we have a survey that was done, and it found that 16% of people text while driving. Uh, then usually when you have the 16%, there's another little number off to the side that they publish, which is a plus or minus percentage. And this is one way of approximating that number. So what is the error, and that's that plus or minus number, of this poll with 95% confidence? So in other words, it has a 5% chance of being a little higher or a little lower than 16%. And we're going to contain it within a large interval. So when 150 people are used in the study, we're trying to find out with 95% confidence, what is the error of this poll? So the approximation formula is this. The true formula is really quite complex. Um, so the error of the poll is plus or minus 100 divided by the square root of n. It's a very simple formula. And of course, this is going to be based on a percent. So when we get this number, it'll be a percent up and a percent down. Up is the plus, down is the minus. So what happens is you move a little bit to the left of 16% and a little bit to the right of 16% based on this error number. Okay, so the only number that we have to worry about is the n. So then this becomes 100 divided by the square root of 150 people. So this would be the square root of 150 people. So when you type in, you can't type in the plus or minus. So the only thing you can type in is 100 divided by the square root of 150. This is going to give us approximately, I'm going to round it a little bit, 8.16. So this would be an error of 8.16%. So what that means to the survey is you have to take 16% and subtract 8.16. That'll give you what's known as the lower bound. And then go back to the 16% and add the error of 18.16, or 18.2 if you want to round it to the tenths. So the lower number, minus 8.16, is only 7.84%. And the highest it can go is 16 plus 8.16, which would be 24.16. So just based on the small survey sample of 150 people, this is a very broad range of percents. One of them is less than 1 in 10 people. The other one is almost 1 in 4 people. That's a very broad range. So more than likely what would happen is that this study would have to be done with a lot more people involved to get a better feel for what the true percent is. In other words, you don't want your error to be more than usually 2%. So another way of figuring out how many you should survey, what we have to do is we have to take our error formula. I'm going to write it a little small over here. And we need to solve for n. So the first step in solving for n is, because it's in the bottom, you really can't solve for it, so we've got to force it to the top. And one of the things in algebra that you should know is to get rid of fractions first, you multiply by the common denominator, which happens to be the square root of n, and you want to multiply it by both sides. So on the right-hand side here, the square root of n is going to cancel, and all you're left with is this 100. And we're going to ignore the plus or minus in the formula because that's just going to get in the way of the algebra. All right, so then we have e times the square root of n is equal to 100. Now remember, our goal is to solve for n, so we would need to get rid of all the junk that's around n, and the easiest one to get rid of is e. So we're going to divide both sides by e. And therefore, we're going to get the square root of n is equal to 100 over e. And all we're looking for really here is how many should we survey n to get a certain error. Like I said, this one's way too big. So when we solve for n, to get rid of the square root, we're going to square both sides. So we're going to get n is equal to, in parentheses 100 over the error, all squared. So let's say we wanted the error to be a lousy 2%, so that it would only go 2 up or 2 down, 18% down to 14%. That seems more reasonable. 14% to 18% is a lot closer to 16% than 8% to almost 25%. All right, so if we want our error to be 2, we just have to plug it in there. So we're going to get n equals 100 divided by 2, which is 50. And we're going to square 50. And that comes out to be, let's see here, 50 times 50, that would be 2 zeros and a 25. So we would have to survey 2,500 people to get a better error of only 2% on the survey. And two things might happen. The 16% could change and it could bounce anywhere between these two numbers, but it would settle down on something in between them. And then we would have to just go 2 up and 2 down from it and get a very good feel for what is the true percent of people texting while driving, which, by the way, is not a good idea.